let's get into it. Right, okay, so I have finished doing the pesky version of GridRunner. So here we go. No sound, because sound is a black art to me, but it's working. There we go. So fire. I'll wait for the snake to get close by, try and kill it. Oh, not doing too bad. Oh, missed him. Oh, down. I've got to go down. Too close. Got him. There we are. Level 2. Oh, I've just noticed a bug. I've just noticed a bug. Let's see. Yeah. Just noticed a bug. I'll have to get that done. What, finishing this? Right, so it should kill me. There we go. Yeah, there's the bug. My number of lives is wrong. It's 1 out. Let's get rid of all this. Right, it's 1 out. So, lives left must be, it's 4. And that should say 4. Here we go. That's better. See if I can die quick. I think first. Oh, missed it. Right. Let's see if I can. Think about that. Oh, 1 away. Here we go. Dead. Right, I'm down to 3. Still on level 1. Oh, and the snake is still there. I thought that was a bug. I spotted that earlier. Hang on. Need to sort that out. I think. Where is it? Where is it? Activate game. I think that's the one. Nope. I can't remember where I put it. Okay. Clear bomb array. There we go. That's what I was missing. That's it. Right. The reason I 50% chat finish. Right, the reason I know what I'm missing because I've got a de-evolved set of code because what I wanted to do was to now start making this code multi-platform, as in currently works in the C64. Fine, there's no sound yet. Right, we shouldn't get a second snake now. There we go. And to show how we can use one code base to make this run on multiple systems. So I've taken a copy of the code. I reverted this back to before I'd done it. I've got the code here because one of the things is I don't want to have to spend a lot of the stream reading up about the pet, right? Because I'm not an expert in it. I know enough to be dangerous, but I'm not an expert in it. But what we're going to do is I'm going to go through what I went through to convert it to a pet, right? And if all else fails, I've got it over there anyway. So the first thing we need to do is we need to be able to set a variable that says my first computer was a VIC, but the school had a CBM Pet 432. So before the BBC, before I was on the BBC, so the pet has a little place in my heart. So that's why I want to do it. So what we're going to do is we're going to use this code base here as our code. Black and green are the colours. Yep. Yes, mate. There was computers when I was at school. May have been one, but they had a computer. They had one, and then they bought 4, so they had 5 in the second year, and then in the third year they had a BBC Micro, and that's when I took over the BBC Micro for pet. Colour, here we go. Oh, I schooled in Hatfield, and then moved down here. Hatfield High, yeah. But I left in Hatfield High. No, not Hatfield High, the school I went to. Hatfield High didn't... Right. The thing is, at Hatfield High, they thought I was thick. They thought I was absolutely dense as the fog that descends on us at night. And so I was in stream F, I think. They thought I was as thick as 2 short planks, and I was in the schooling where it was, not expecting a lot from me. And then we moved in 1980, 1981, somewhere around there. And the school I went to, they had a pet. They had a pet, just the one, and because I was a new kid, they put me in the top class. Let the mighty fall, but I didn't. I stayed in the top class, so I did computers and all that. But yeah, they had a pet, and then the following year so I was late in 1980 or 1981 is one of the two. Then it was a 6-week break, and then when we come back, they had 4 more. So there was 5 pets. And then the following year, they got a BBC Micro. So he was, yeah. Hatfield High bought dragons, did they? Well, mate, if I'd still been in Hatfield High, I don't think I would be in the computer job, to be honest. I'd probably be a labourer or something, because they thought I was thick. So it was the best thing my dad did was move. and I've always thanked him every time I've seen him. Anyway, so let's get this checked into Git. Right. So there's this and we may have, I don't know, are you the same age as me? Or you might have been in a lower form, I suppose. Or you might have gone in there when I'd already gone. Yeah. So I would have left before you'd got there, because I was only there for 1 year. Anyway, till tomorrow. So what we're going to try and do is we're going to try and make this code. So we're going to use this code that works for the 64, and we're going to assemble it for the PET. So I was using labels until Shallan told me about the define variables. So I messed around with that, and I thought, oh, this is brilliant. And then I finally got this book. Yes, ladies and gentlemen, it arrived. Finally got it. Anyway, but one... Shut up. But one of the things in the book was about, because it's using VS Code and Kit, was about using workspaces. So we're going to use the same thing. We're going to use a workspace to assemble for the PET. We're going to use a workspace to assemble for the 64. And we're going to use a workspace to assemble for the VIC, the Commodore 16, +4, 128, and so on. So what we're going to do is we're going to create a workspace specifically for the 64, make sure it still works. Spectrum, no. No. And then we're going to create the PET version, and we're going to run through all the code to see what we need to change to make it work on the PET. So, first things first, we need to put the code into a directory that is on its own, because at the moment it's in the root directory. So we're going to create a directory, and we're going to call it core, just for the sake of argument, and we're going to copy all that lot and put it into the core. That's if it'll do it. Oh, it doesn't want to do it. Okay, it's not a problem. I'll do it myself then. Here we go. Done. Now we can create our workspace. So we're going to create a workspace for the 64. So here we go. Save workspace as. So we're going to call this C64. And we're going to... Now we need to populate it. So what it's saying is it's going to look in this folder for all the stuff, but I don't want it to look in there. I want it to have a folder of its own. Drag it in there, move. Yeah, I know. Get rid of that. Open Workspace. Go into here, grab it. Now, we can now add our core folder, because at the moment the Workspace is only looking at the current directory, which is derived by this. So we're going to say add folder to Workspace. So we're going to add the core. There we go. So we've just added the core into the Workspace, and it's also changed the Workspace parameter. We're also going to, we need to specify what emulator we're running and stuff like that. Now, I have already got the settings already set up because I can't be bothered to go through it. There we go. Now, to get to the settings, you come down here, settings. There's a new one come up called Workspace, and in there you go to the kick settings, and it will take on what I've just put in. So there's the emulator, and I think that's all I put except for the the startup. So this is the startup file. My Blue Peter moment. Here's what I prepared earlier. Now, so we're going to create a new file in here, and it's called c64.asm. And what we're going to do in this file, we're going to define #define c64, and then #import back, and it's pet. I think it's that. Is it? Let me just check. Oh, hang on. Yeah, it doesn't like it. So, back. Oh, I've got to put a double. Anyway, F6. Why didn't it load? But I've done it. Oh. That's why. I don't like this. Is it escaping it? There we go. There we go. Now, let's get this that size. So it should be exactly as we had it. We've just got a different way of starting it up. I've just noticed it's one column short as well, but we'll sort that out later. Now we've got that workspace. I don't think the direction matters. Okay, let's try it the other way. Yeah, you're right. Why isn't that remembering my size? There we go. So now we've done the 64, we can now go and do the pet. So we need to open it back up as a folder. Create another folder, it's called pet. In there, create a new file, pet.asm, and we'll copy that, paste it into there, rename it, And then here it says open workspace, so you can just open it. And now it's in pet mode. And have you noticed the C64 directory's disappeared? So now we're in pet mode. So the first thing we need to do is we need to define pet. And then do exactly the same as before, import but if I press F6 now, it's still going to run Vice, as in the C64, right? Now we don't want it to do that. We want it, when we press F6, we want it to run the pet emulator. So just in case I get it wrong, I've got it here. So we need to change this to xpet. We also need to tell it that on the pet what specific options we want to give it. Now we can do this by doing the settings. So if we go into settings and workspace, extensions, and then kick, all you have to do is look for the assembler command options. Here are emulator options, and in there we just put in -model 4032. So we want the pet emulator to work in 4032 mode. All right, save it. There we go, it's put it there, and the startup is that, which is this. And what it is, because I've done that, because this is our main file. So if we import that, then that imports everything else into the system. We've still got access to all the files here. Yeah, still got access to all the files here, but it's just a way of separating out. We are now in pet mode. Yeah, so if I F6 this, now it's going to crash, but the Vice emulator, the pet emulator, should fire up. There you go, and it's in 4032 mode. So let's see if we can make this bigger. There we go. Save settings. Is there anything we can do with the display? Have I got it? Yeah. No, ×2. There we go. Let's try that one. Yeah, that'll do. Save settings. So now it's going to assemble to the pet. Now this is where the clever thing is, which I thought was really, really clever, the way Kik uses it. We are now going to go through all the source code and define what is pet code and what is not pet code, right? And then when it comes to assembling it, it will only assemble the bits that we specify. So, starting at the beginning, because it's a good place to start, pet matrix. Now, the pet has a different starting point than the Commodore 64. So, yes, we are going to petify his bits. So straight away here, this will not run on the pet. So what we do is we use this #if. Yeah, and if pet do something else, do something else, and then end if. So we're saying here, if it's a pet, do something. If it's anything else, do this. So at the moment, we need to copy that, paste that in there, and we need to change it to, and let me get that up. Oh God. Pet. Here we go. So you know I've got this book, but I'm going to use this instead. So let's get to the important bits. Memory map, where are you? Declose. Keep going. Oh, assembly. Memory map. So that's 0 page, blah, 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 blah. And then page 3, page 4. Here we go. Start of basic is 0401. So that's where we need to change our startup, yeah? Now I'm using basic startup because basic startup doesn't assume that you are you're starting at 0801. All it does is create the 10 sys, whatever your start value is. You have to specify where your start and end point is. So that's what we're going to do here. 0401, 0410. Now if we run this, it will run. It will crash, but it will run. So what we're going to do is we're going to change things that are going to allow us to get it to run pretty quickly. Yeah. So if we go into the constants, we need to do something here. So hash if pet do something else, and then I'll just put it here for the moment, end if. So all this is for the 64, yeah? But what we need is this lot for the pet. In fact, we don't need the color RAM and the color offset, so we don't need those two, yeah? So screen is not at 0400. The screen is at, if you know your pet, the screen is at 8000. And it doesn't say here, it goes straight to that. But the screen is at 8000, believe me. So that's where our screen RAM is. And the screen is still 1000 characters. Ask it where his screen RAM is, or her screen RAM is. Yeah, exactly. Now, this row low and high. Remember when I was talking about that on the 64, there is a matrix of there's a matrix of information which tells you where the start of the lines of the screens are. Yeah. Now, on the 64, it's 0 page D9 for the high bytes and an address ECFO for the for the low bytes. Now, this book really disappointed me because I thought it was going to let me know where it is. Now, I can show you where it says it is. Let's get down there. It's in the E's, D's, E's. Here we go. Right, here we go. Now, it says in this book, right, so it says in this book, where is it? Must be on the next page. Oh, it's around here somewhere. Took me ages to find it. It might take me ages again to find it again. Here we go. Here we go. It's here, look. here. And so what this is saying is, because the CBM had different basics, so we've got basic 1, basic 2, basic 4 with 80 columns. And so when we run this, so it's going to crash, but that's okay. Right, we're in basic 4, yeah? So basic 4 says the table of low bytes which mark the end of each screen line is at E65B. Okay, so we've got the emulator open. Let's have a look. All right, so let's put that there. I can't make that text any bigger, sorry guys. Hey up, the legend is in the building. Welcome Derek, how you doing? So let's have a look. Where does it say? So basic 4 is E65B. So let's do memory E65B onwards. Now when you look at that, that doesn't look like low bytes for the screen RAM, because you've got to remember, right, we're in 40 column mode, so it'll be 0, 28, 50, 78, AO, blah 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 blah, and it's not there. It is not there. So this book is talking rubbish, and I was really disappointed. But there is a way of finding it, because if you do hunt 00, oh no, hang on, we have to put the start and end address, don't we? So E1000 to FFFF, and then it's 00285078AO. Right, they're the first 5 bytes we need to hunt for. So if you press enter, there you go. It has found that sequence at E798. So let's have a look. Memory E798. And there you go. 00285078AO CA FO18. And it carries on for 25 bytes. So that's what, 4, 8, 12, 16. So 20, 24 there. That is the low byte range of the screen. So yeah, I want a pet kit. I want a pet kit as well, mate. So we need to change this number here for the pet. So it's come up as E798. So we need to change that to E798. All right. Now back to the PDF. Go back to 0 page. All the way back. All the way back. Oh. Now for the 64, it's D9. 0 page D9 has the high bytes. All right. But if we look at D9, oh, last key input. Oh, okay. And if you just look a bit further on, you see it here. 40 column machine, table of 25 high bytes for the RAM address. Willow wants a PS5. So we need to change also. It's not D9, it's E0. So that is now specifying our X and Y for when we want to place the cursor. Which model? So the problem now is if I try and run it. So let's close that down and close that down. If I try and run this, it will crash. Oh, color offset. Oh yeah, because I ain't gone through it. let's get rid of all the colour stuff. That's what we need to do. So colour, we need to find all the colour stuff, or it's just going to throw a fit every time we do it. Here we go, colour offset. So hash if pet hash else. So we'll copy those two lines, and then we will hash end if. So that's now taken that out of the pet. So have we got any more colour in there? Char colour. Here's another one. So paste that in there, and here, and if. So that's getting rid of that colour out of there. Oh, we need to go in there in a bit. Let's just get rid of all the colours, colour information. Right here, there's another colour. Hash else, end if. Any more colour in there? Nope. Right. Colour in here. Yep, here. Put that in there. Ship colour. It's a bit tedious, but you know, if you write it right, it should do it. Bullet character, ship character, grid color. Here we go. Character color. Cool, that's a funny way of spelling if. Right, lasers. Now I know there's colour in here. There. 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 Pod color. Jar dead. Any colours in there? No. Any colours in here? Oh yes, there is. There's that. Right, we'll get rid of that. So that's colour. Any more? Nope, not in there. Player dead. Colour. Oh, is that it? Right, colour. Here we go. Any colour in here? Bomb character, animation character, grid colour. Any more for any more? Nope. Setup. Oh, there's bound to be colours in here. Let's have a look. Oh, there's that. This for a kickoff. Don't need to do that. In fact, we'll do that. We don't need to do that. Danger border. this can be taken out altogether. Where are we? Drawing a line. Okay, so there should be a colour one here as well. Here we go, grid colour. What we got here? Right, better take that out because that's a SID. Any colours? No, but there's one here. Right, not many to go. Char colour, show character at the point. Oh, we'll get there, we'll get there. Oh, I can't be bothered to take them out. I'll take them out in the routine. Show colour at point here, placement colour, check it out there. Materialize ship. There's a colour aspect to that as well. Ooh, wrong place. Exploding ship. Yeah, there's the colour aspect to that one. Right, SID. Well, we're not using that at the moment. Right, snake. Grid colour. Snake colour. Snake control. Snake character. Snake colour. Colours again. Body. Snake head. Any more for any more? Oh, there's another one. Right. That's that. Storage. Right, here we go. So we don't need that. So what we're going to do is we're going to move stuff around because we need that. So we'll move that up there. But this can go in there. Yep, that'll do. We also need the oops, unscrew. Need that. So grab that, put that in there. Grab that, put that in there. That's the 64 version. So we need to grab them and put them in there, and that'll be the pet version. So we need to work out these character places, which is pretty easy because all you're doing is 8,000, right? So that is 817, 816E, 80, 80, 80, 80, and 80. Easy peasy. Right, so that's that done. We've eliminated that, so that'll be taken out. Let's grab that just in case. Right, utilities. Right, so we don't need this here. We don't need that for the pet version. To there. And we don't need it for that for the pet version. There. Right, so this is okay. This is okay. This is okay. Capture joystick, don't need that. But I'm going to leave it in because I'll show you what I'm going to do with it. Get row, put character on the screen, color. Right, we don't need that either. To there. And then pet matrix. Yeah, we're going to be doing some bits in there. Right, so this should assemble. Ooh, danger, danger, Will Robinson. Game setup, line 84. But we're in pet mode. Why are you there? We're in pet mode. Okay. What we broken? Oh, colour. Colour, colour, colour. Where's that? Oh, missed. Oh, I need to make that listen command, don't I? Have I missed? Oh, I'll find it. I'll find it. We've got this colour anyway. So, where are we? Game setup, line 78. That's here. So, let's do that. Let's find this end if. Nah, they're all done. No, they're all done. Right. Let's see if it'll run now. Oh, still got a problem. Where's that? Game setup 117. It's definitely that game setup 117. Oh, I forgot them, didn't I? Missed that out. But hang on, that's the pet. That shouldn't be in. Define pet. That shouldn't be included anyway. Oh, did I take it out from here? Danger colour zone. Yes. Yes, I took it out. else if pet, that should not be including it. It should be including that, but it shouldn't be including this. It should be filtered out. Oh, if pet, oh plonk.
Hi, John here. Another subscriber. Stay a while. Stay forever.
I got a subscriber. Oh, Microman, thank you for subscribing. 4 months. Wow. Right. We have a problem, Houston. We have a problem. Yes, you was correct. You can have some points. We have a problem, and it's saying it's jamming at FFFFE. Now, the reason it's jamming at FFFFE is because of... Let me shut some of these down now. I'll keep the one I need open. It's the very last one, which is this one. And it's jamming because it's trying to put the cursor at a specific point on the screen. So for the C64, there's a kernel jump vector that allows you to specify where the cursor is going. I've lost my train. Right. So the jump vector FFFO in the C64 allows you to specify where on the screen to put the cursor. So when you print stuff, that's where it starts. But on the PET, there is no such thing. There isn't a bean about it. And what we need to do is we need to find another way of doing it. Now, I tried many things. Many things. And, yeah. I did a routine to print down and left and stuff like that, and it was just an absolute pain. So, but there is I thought there's got to be a way that the PET's doing it. It's based on the same kernel, near enough. They just don't have a jump vector to do it. Now, the jump vector for FFFO is like E9 something. So I thought, right, better look in the kernel and see if there's anything in there. And I've lost it again. Here we go. That will give me an idea. And the first thing I thought of was home, print home, right? There's got to be a print home. So I was looking through here to find print home, because that has got to clear the screen and then put the cursor in the top corner. So there is a print home. Well, I'm on C still. E. Right, here we go. Oh, that's F's. Too far. Right. So, it's somewhere around here. Oh, have I gone too far again? Oh no, I'm still in D's. This is really annoying. It jumps about all over the place. Because I'm in D's, E's. Here we go. Right, E's. We're looking for the home cursor, and here it is, right? Can you see it here? Print home. So if we looked at that code, we could find where it's resetting the cursor, right? So let's fire it up. Wait for it to crash. None. Going to monitor. Right, so it said llamasoft. That's definitely what it says, isn't it? Basic for llamasoft. Yeah, home cur llamasoft. There we go. llamasoft. Let's have a look at there. So disassemble llamasoft. Oi. Disassemble llamasoft. Right. Let's make that a bit bigger. Here we go. So here we are. Hello, Kebab. You have most of this pet book memorized. Wow. So here we are. We're clearing the screen. So that's clearing the screen, and then here, look. He's setting C6 and D8. Right? And the dead giveaway is, look, there's my parameter for the high row bytes. So we're on the right track, look. We're on the right track. So C6 and D8. So they're two numbers that we need to look at. It's loading the high byte. It's ORing it with 80, storing it away, and then loads the low byte and then stores it in C4. Right. Okay. We can do something there. So what's that starting at? E071. So we could use the routine E071. So it's loading X from D8, and then loads loads where it is, and then use that's where it gets the low. Right. Okay. So we need to know what D8 and C6 is. C6 and D8. All right. C6 and D8. Keep going, John. Come on. Quicker, quicker. Fingers, quicker. There we go. C6. D8. Right. C6. Position of the cursor along the line. D8. Screen line of the cursor. Right. We can use that function to perform the Commodore 64 plot. So let's get in there and do it. So we're going to create another file, and this is going to be, in fact, do we? Yeah. No, we're not going to do it in there. We're going to do it in here. Another file called machine specific. And in here we are going to, we'll copy all the common stuff. There we go. Hash if pet, hash else, hash end if. So what we're going to do is we're going to take over the label KRL jump plot. So we're going to take over that. We're going to override the constant. And so we're going to use the same thing. So it was Y is our line, so that goes into C6. Or was it X? Let's go back. Let's have a look. D6, D8, sorry. Screen line. D8 is screen line. Okay. And then it was E071. Now, if we go into the constants, we can find that constant. There it is. So we're saying that this is not going to define what CRL jump plot is, but our machine specific code will do. And so we're going to put that into here. Put that into there. Right, let's see if we get anything out of it now. And the crowd goes wild. Don't worry, it's not gonna work after this. So if I press space, see, I'm pressing space. Right, so the problem there is we have in our constants that we're looking at the keyboard at 197. Now that's not right. This is for the 64, right? So we need to give it the pet equivalent. Now the pet equivalent is a different address, and it is if my memory serves me, because I had to go into my pet Frogger code to find the address, because it doesn't say it here, right? So I'm going into my pet Frogger code. Hang on, where is it? Here we go. To find what the address was. So here we go. It's down here somewhere. Print, print, print. Print, print. Number of lives. Here we go. That's it. 97. There we go. It's 203 or 151, depending on which version you are. 203, that's ours, isn't it? Because it's 197 and 203, the two addresses, aren't there? What's at 197 here? Oh, that's the... Anyway, so it's 97 or 151. So we need to change this to 151. And then we the keyboard isn't the same either. I'm not sure if it says it in here. Let's see if it says it in here. It's somewhere around here. Oh, that's still D. Ooh. Oh, that's the cross matrix, but it's not the value. So what I did was, let's reset this. I think it's keyboard test. No. What do you mean file not found? Oh, I'll just type it in. So I had to find all the keyboard things. So you've got to remember that the PET has the keyboard, the number keyboard on the side. When I was at school, I never knew it had a joystick. Remark out everything you're not using in the PET line. No, the whole point of this is to use the same code for the 64 as well as the PET. So you don't want to be rimming out lines, because then it won't work for the 64. You just shared 64 resource. Ooh. Alrighty then. Nice. Oh, it's actually got all the numbers in as well. Nice. How come this says 8000 to 99F is optional carriage ROM space when it's where the screen is? Hang on. This is the VIC 0 page. Sorry, the 64 0 page. Oh, it says it at the top. It's not the PET. Anyway, so we have to, this lot here, the 197 codes, we got to rem out. So if PET, do that, else do this. So here's something I prepared earlier. So I went through and just got the codes for the specific ones I want. So return's going to be fire. No, the 0 page is a difference between the 64 and the PET. They are different. They're not the same. So the scan code for return is 13. That's going to be fire. 4 is 52. 5 is 53. 6 is 54. 8 is 56. 2 is 50, spacebar is 32, and no key press is 255. You have both addresses. Oh, I see. Okay. Let you off. It's the first column here. Okay. So now we've got the right key codes. We should be able to advance, because now we'll be testing for the right key, the right place. So press space. Right, okay. Next problem. It's not clearing the screen when it does a clear out. And that is because of this here. Because if you remember that the screen is at 8000, so the high byte is going to be yes, it was, yeah. The 8000. So the 8000. So we've got to rem this out, right? Got to rem this out. In fact, that's 1, 2, 3, like that. Because we don't want to AND it. We can't AND it. So this is a 64 feature. So hash if pet do nothing, hash else do for everything else. So that should now fix our screen clearing problem, hopefully. There we go. Boom, boom. Hey, look at it. Look. It's sort of working. It's sort of working. Yeah, it's sort of working. Now, this took me this took me a long time to figure out this bit. A long time. So what's happening is, because we're looking at the joystick port, which is at 9000 something. Sorry, DC something. That is in ROM, and so it's finding the same byte all the time. And did I kill everything without moving? and so it's just constantly firing. I can't do a thing. So what we need to do is we need to redefine the controls. Now I'm not going to write that. Right? I've got it already. So what I'm going to show you is what I did. Yeah. So it's in the joystick capture system here. So if we go to the joystick capture system here. So what we're going to do is we're going to get rem out the stuff we don't need and put in the stuff we do need. All right. So and what I've done is I see 64. So this is what we need for the 64, and then if pet now I'm not going to type it in, I've got it here. Right, I've got if pet twice. That's it. So let's just make sure, yeah, that's right. So what we're doing is if it's the pet, we're loading from the keyboard, right? So the pet's going to be, use the keyboard. So it's 4 and 6, 8 and 2, and returns fire, all right? So what I'm doing is I'm reading the keyboard and then setting the joystick value, the equivalent joystick value. So I'm reading the keyboard, testing for no key. If it's not no key, then I'm going to test for the return. If it is no key, then I load 0 and exit. And exit comes out and stores the value into the joystick input. And I test all the different keys and then set the corresponding joystick value for those keys. So we don't have to go into the depths of the control system to rebuild all that. All I'm doing is I'm taking the keyboard value, mapping it to the joystick value, and then sending it on. Now this can be done a lot quicker and a lot easier, but for now we're going to do it this way. If the other way I was thinking of doing it after I'd done it was to have a matrix of the keyboard value to the corresponding joystick value and just scan the matrix for the right one, which we can do in a bit. So this now will allow us to move the ship around the screen. So if I press F6, we should be able to control it now. Oh dear. Now that is a separate thing. So you've got to remember we was reading a joystick value from a byte that was randomly spitting out things. Now, because we're now looking, our thing that slows the game down on the 64, our raster test, doesn't work on the pet. So we have to slow it down manually. So here, so we have to slow it down manually. So basically all I did was I just run my delay routine. So utils dot, I think I put it single stage. Yeah. So every cycle I'm just delaying it. So now it should be a little bit more playable. So it should slow it down. So here we go. There we go. But the problem is, if you notice, the lasers are not coming up from the ships. I mean, I'm firing all right. Yeah. I get points for there, but the lasers are not coming up. And oh, that was a right pain at the backside. That one. It was because when I was writing this originally, it was for the 50 cassette 50. So I was optimizing while I was going, and what happened is this here, this jump, I had to convert it into a JSR and then RTS. Because it was jumping away, but the problem was when you're in pet mode, it doesn't do this, so it just goes straight through, and then the lasers weren't working. Now that took over an hour to figure that one out, but now we should have a playable C6 a pet game. Here we go. Right, let's see what I can do. Go on. Oh, I missed it. Go on. Missed it again. Come down one. Oh, sneaky. Missed it again. Ah! It's very difficult to see on this matrix. Very difficult to see. Oh, blew up. Right, so there's a problem, is that it's very difficult to see what's going off because everything is green. It's just a wall of green, yeah? So what we need to do is we need to change the game character, the grid character, which is here. Where is it? Where is it? Where is it? Grid character here. So we need to change that. So if it's a pet, then if it's a different system. Now, so we need to find a character that we're not already using, but still will work. So here's the screen characters, and I'm using quite a few, yeah? So we can't use space because the space all around the edge is the terminator for the snakes. They look for the spaces so they do the rotation. So we need to find a different character, and I was looking at using, you know, a comma to have little commas on the screen, or trying to find a character that wasn't invasive. And then speaking to my dad, and he went, you know, there's another space, don't you? What? There's another space. So looking at this, right, so here's the space that we know and love, but if you look at this side, we have another space, character 96, and apparently it's shift space. So if we change that to 96 and then run it, we should end up with a grid that is playable, because what it does, it gets rid, there we go. So now we've got an empty grid, so we can see what's going on. Oh, I nearly had him. Oh, come on. That went straight through me. God. Oh, I'm rubbish at playing my own games. Rubbish at playing any game. Come on. Got one. Got another one. Ah, git. Oh. No. Come on. Gonna die, gonna die, gonna die. Oh, no. Right, come here. Oh, laser got in the way. Ah! So there we go. We have a working Well, it was working. I'm disappeared. I must have died. Now, why have I not appeared? Let's run that again. See if I can recreate that thing. Pressing the wrong key. You notice how it slows down when I press a key. Oh, missed it. Got that one. Yes, got them both. Getting to level 2. Two snakes. Right, so you can see it. You can see it now working for the pet, right? And just to show you that I'm not giving you any sort of rubbish, let's go back to the C64 one. So here we go, C64 Workspace. So now in the C64, let's fire that up. This should still work. There you go. And that's how you can make a game use the same code but work on a different platform. Now I was in the middle of doing the VIC-20 one, because the VIC-20 one actually, because it's a smaller screen, we have to readjust everything. Well, I mean, we could try and put all them in, all the VIC stuff. But I got stuck on the joystick, because they've got a weird way of having to do the joystick. That's where I got up to. But it's just trying to show you that you can have one set of source code that then you define a variable to say which bit you want in and which bit you want out. So you have to be careful when you bring in and you bring out variables, because code, because if you take out of constant but you still need it, you've got to put it back in, right? And so you have to think how you're going to do it, and especially with the VIC, it was really took a lot of time. Took a lot of time to get the screen locations right. I was poking all sorts of places, but we can do that. I mean, I've got it here, and we can do the same sort of thing. I've just noticed something. This is only for the 64. That's only for the 64. So we can do the same sort of thing for the VIC-20. So if I go, let's go back into and open the folder. There we go. So let's create another folder. VIC-20. Oh, it's in the wrong place. There, thank you. Folder. No. Folder. Thank you. And in there we'll take that and we'll take that, paste it in there, rename this to Vic. Rename that to Vic. So this is Vic 20 and this is going to be Vic. Right, and memory configuration. Vic 20. Okay. Right. Dash memory. Right, okay. Dash memory 3K. Right then. Open Workspace. Here we go. So this is now Vic 20. And we do basically the same thing again. Oh, you're all talking about Mega 65. Okay. Now I'm going to cheat a bit. Let's do this. Right, so the Vic has got a different loading point, which is actually the same as the PET. But we are going to create 3 different separate ones. So we're going to do end if. This one can be if C64 set, and we'll have one for the Vic as well. .401 .410. Because we're going to use the 3K expanded model because the code doesn't fit in an unexpanded Vic. It has a bit of an issue. So we need to now change the we need to create some change the constants for the Vic. So if we go into the C64 constants, we need to set up the constants. So here we go. So else if C64 L if Vic 20, and we are going to copy that. So the Vic screen RAM in unexpanded mode is 1E00. The screen size is it's half, isn't it? It's half of it. Yeah, so it's only 512 bytes screen size. The memory is at 96 if my memory serves me right. which means the offset is going to be 7, 8. Right. Where's my Vic book? Where's my Vic? Mapping the Vic. So we're now looking for the memory address locations of the Vic. So it's got to be around here somewhere. Let's try E0. Is it same as E0? Here we go, screen linking table. So, so the screen linking table is D9, and it says down here EDFD. So D9, EDFD. EDFD. Okay, so that's working out the screen. Is that on 197 still? Oh, we can get rid of that now. Is it still 197? Matrix coordinate of keyboard. Yep, so that still works. We haven't the where's the jump vectors? If pet, yep, that's right. Because we can still use the jump vector for the Vic, and the keyboard. Yes, the keyboard. Right. #L if Vic20 is exactly the same as the pet, would you believe? Right, so that's that. Now, the Vic has a raster line. So we can reactivate the raster line, but we need to remap the Vic raster here. Where is it? There. We need to remap this. So if C64, then it's this. Else, for the moment, we'll just do an else. It's going to be that. So the Vic raster for the Vic is 9004, I think. There we go, 9004. So this is where the raster is. It doesn't say how big it is, but I ran a little program and it got up to 145. So we might just use that. So 9004. 9004. So in our here, we need to create another constant to allow us to set the raster line. So I think I may have had already done that. Let's have a look. See if I've got a raster. Yeah, raster line 240. So that needs to be converted into raster line. And here we need to do if C64 else now 145 is what I worked it out to on the Vic. So we need to find every place where I'm using the raster. So that's going to be in setup, I think. I'm using the raster in the setup. Yeah, it would be there. That's one. I think there's another one down here somewhere. Ah, there it is. Yep, that's that one. And I think that's it. So that's the raster line set. But like I say, we need to change the screen layout. And this is where it gets a bit tricky. So in the game constants, we need to change this layout. So at the moment, we have got the VIC is the only thing that's different. So if VIC20 hash else, because the PET and the 64 have the same numbers. So number of levels all the way up to the top. So copy that and put that in there. So the row length is 22. 23, sorry, the column length, the row length is 22. There's number of rows is 23. We have a matrix size of 21 because we use 2 rows at the top. So that's going to be 20. 38, so that's going to be 20 there, 2 less than the size. Top row is stays the same as 3. Matrix ship. Now we're talking 24. We'll make that 11 because the VIC screen's smaller. Bottom row is 21 because we need it 2 from the bottom. That's right. This needs to be 1 from the edge. Number of maximum levels. I don't know why that's in there. That's got to do with leveling. Right, so 22 columns in a row, 23 rows on the screen. So the matrix size is going to be 20. Column size is going to be 20. Yep, that should do that. Now, is there anything else? Screen location. Yes. This fella here. Right. So, C64. Else if VIC20. Else if PET. Oops. Do that. So that's going to be 1E00 and that's going to be 8,000. Right. Anything else? Color, yes. No. VIC20. Now the reason I'm doing this is because the VIC doesn't have orange as a color. So what we're going to do is going to make the grid green. And I think that should be it for that. Now in the memory we need to change this because we've only got 22 columns to play with. So this needs to change. So if VIC20 else, because the PET and the 64 have got the same number of columns. So for the Vic, it's going to be 0. Right, let's move down. So do that. Okay, and here again as well. Right, so for the Vic, we're going to shorten it. And I shortened it to this. Like that. Which was just enough characters to get it on the screen. Oh yeah, gotta do this as well. Oh dear. Right, let's copy this. Now this works out to different numbers. So the different numbers of no, that works out to the same numbers. I had to shorten it, didn't I? OSK presents. That's it. And then this is the same. We have to do the same here. So let's grab that. Oh yeah, it was the numbers that were different. Yeah, 211. So I don't need to do that. We can take that out and put that there. So it's just the numbers that are different. Numbers were different there as well. Numbers were different there, which was 1 and 15, and we lost the smiley face. And this needed changing as well. And so this was 3, and we just went entering zone. I think that's what we did. Yeah. And no, danger zone. I suppose entering zone would be better. Right, it's that lot. Now we have to change a load of game memory. Where was I? Oh, I'm not remembering all this lot. I'm just copying it. So if C64 so L if C64 elif fic20 put that there. Now this was 1F03. I'm just copying out of my borders. Zone was 1EC8. 1EC8. Pod starting point was 1E2C. scoreboard was 1E02, 1E02. High scoreboard is 1EOC. Leveling in was that. Lives is 1E13, 1E13. And then here, so that's L if C64. Vic 20. Oh, we could get away with else on that, couldn't we? Could get away with else on that. I'll try that. Game constants, yes. Yes. That's the one there. That needs to go in there. It also needs to go in there. But that number needs to be made 18. We also need raster line. Where's raster line? That can come out there now. Raster line's done. There. Right. Let's see if we break it. Okay. That's in setup, isn't it? Need to change the colours. Right, so black. Hash if vic20. Store. Oh no, because it's board. Yeah, let's do this. LDA ash. I think it's 8. Store it. I think it's 901. 901. No, it's not. It's 9007, I think. 9007. Let's have a look. No, it's not 9007. It is 900F. There we go. 900F. Right, so what do we need? Bits 4 to 7 are the background. So we want that to be 0. And bits 0 to 3. Here we go. So if we want the background to be black and the back to be black, we need to poke it with 8. Okay. So black on black is 8. 900F. I think that's what it said. Yeah. Right then. There we go. There we go. Press space. Get all the flashing lights. Now the grid's white for some reason. It should be green. S94. We're one out. One out on the lives. The whole thing's one out. Let's make that one. Okay, so why did the lines not get set up? Why didn't the colours go in? That's the same. Right, drawing lines. Here we go. Did I not? Oh, I stole the colour. Here we go. If pet. Maybe I'm storing it in the wrong place. Looking utilities. Oh, there we go. There we go. That's the problem. Right. Constants. Where's the offset? Thick offset. There we go. Color offset. That's what we want. Oh, I've lost it. Utilities. That was it. So we want the big number color offset. Anywhere else? Okay, let's try it again. Hello, Monsignor WauloK. How's your coffee today? Well, that seems to be working. That's where I got to. That's where I got to, because now I've got to figure out how to do the joystick. But made a 64 version already, VIC-20 version already. Once you get it done, but the problem is the control system's not working. Because the way the VIC does the joystick is a bit troublesome. So and this is where I got up to in real life. So I've now caught up. So I just need to figure out the control system. Now it's got it in here, the control system, but the pins are across two ports. So there's pins there on that one, but I think that is there. The second joystick can be plugged in. So I'm looking for the primary joystick, and I think that's it. But there's only, oh no, it's. Oh, I don't understand half of this stuff. Oh, hang on. Here we go. So poking the data register with 127, so that's every one bar the high bit, then peaking 137 and ending it 28, and then ORing it with 128. So I wonder what that's doing. Then they're re-establishing the data and then ending it with 32. But that's B, ending it with 32. A equals ASB absolute of A minus 100 divided by 4 minus 7. Well, what happened to B? Oh, B is the fire button. Right, okay. So B is the fire button. Okay. So we should be able to do something similar. We should be able to do something similar. We just need to map it right. So 100. So, God, I've got to work that out. How do we work that out? A minus 100. Okay. So we've got, oh right, because it's the 128, isn't it? So we've got pins, we've got bit 7 activated. And then 28, 7, 6, 5, 4, 3, 2, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8. So bit 7 is set. So 28. Alright, so that's bit 0, 1, 2, 3 and 4. 0, 1, 2, 2, 3 and 4. So they must be the 4 directions. So if they're the A minus 100. So if that's 128, at 128 that becomes what? So we're looking for pin 2, 3 and 4 and 8. Right. 3, 7, 3, 7, 1, 3, 7. Sorry. Yeah, 3, 7, 1, 3, 7. Here we go. Here we go. So that's the input output. Bit 5 is the light pen or the fire button. What? Oh, right. Bit 4 is left. So that's left. Bit 4 is left. Bit 3 is Bit 3 is down. That's down. Bit 2 is up. That's up. So that must be 32. So 30 bit 5, that's fire. Okay. So we've got left. Where's right? Oh, 37152. Oh, there we go. Joystick 3, so that's right. That's right, okay. This is going to be fun. This is definitely going to be fun. Right, so what's our mapping? We've got constants. Can we map onto this? Up, down, left, right, fire. Okay. Got to insert the right into there. And then we should be able to do it. Okay. Okie. Why did he? Where's that code? There it is. Why did he do it separately? Oh, the fire. Hang on. Bit 7 is not right. Bit 7's fire, isn't it? Oh dear. Bit 5 is fine. Why? Oh, 152. Okay, 152 with 128. All right then. So 20. Oh, we can do this. We can do this. Hang on. We can do this. We can map it on. So that's the 28. That's the 28. And then we can, yeah, we can do this. Okay, let's try this out. Where's my input routine? Here we go. Right, let's see if we can get this. Here, there's the pet. There's the. Right, let's see if we can get this done. Right, so let's put the Vic in between it. Hash if Vic 20 and if. Right. So the best thing to do is to do the right first. So the right first. So it's saying for right. That's strange. Why are we having to... Why do we read that same one twice? Why do we read that same one twice? Okay, we'll do what it says anyway. Right. So let's do this first, this 128 here. So we got to poke this number with 27. Right. So 37154, 127. And then we read 37152 and 128. Right, let's do that one first. So LDY hash 127 STY into 37157. Oh dear. 9125. Okay. So we're going to read this one first. So 37152. I'm not going to change it to hex, just not yet. 37152. So LDA 37152 and it with 128. So if I ended it with 128, that's right. So we need to now move it down 1, 2. So we need to logically shift it right. Right, let's push that away. And now we need the other one, don't we? So peak 37137 and it with 28. So LDA 37137 and it with 28. In fact, we'll store that into there. That'll do. So that should have put the right at bit 5. Then this is going to set bit 4, 3 and 2. Okay. So if we OR it with what we've got in there, so this is going to set 1, 2, 3, 1, 2, 3, 4. So that's what it's going to do. Then we're going to hex and decimal in the same. I know. I'm gonna convert it in a minute. That should do that. That should put that there. So we store it away. This then should give us that. That's 28, isn't it? And then when we OR it, that should give us that. So that's left, that's that should be right, left, up, down. So they're going to set to pin 5, so we need to logically shift right again. So that should now become right. We'll store that away. Now what do they do? 255 in that same number. And then we 37137 and it with 32. So that should give us something like this. 128, 64, 32. That should give us something like that. So if we OR it with storage, so if we OR it with that, that should then give us 1, 1, 2, 3, 0. Then if we logically shift it right, that should give us that, which is what we want. So EOR #255. Where am I branching to? Not. That's it. Right, that should be the control system. Let's get these numbers sorted out now. Right, 37152. 9120. Uh, 37137 9111. One 28, 64, 32, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. 28. I think that's 28. 1, 2, 4, 16 is 20, 12. Yeah, that's right. You happy now? Oh, you won. You happy now? Not mixed. Oh, upset to you. Right. So that should now hopefully that now should allow us to control it. Cool, that's took a bit of working out. If it works, I hope this works. I do hope this works. Right, let's just make sure I'm set up for... No, I'm not. settings, input, joystick, key set A, define key set A, that one, that one, that one. Close. Save settings. Let's blow this up as well. Save settings. Right, let's see if we can control it with the joystick. There we go. So my in the bottom, that's right. Here we go. Oh, well, we're going right, and we're going up, and we're going down, and we're firing. Right, so it's just the right that we're missing. I can't go right. Okay. So what have I done wrong? So the right is that one. Let's go back. The right is this one. Right. So this is for the this is for getting the right bit, right direction. This is for getting left, down, up direction. And then this one here, this one is to get fire. So we know everything's working bar the right. So let me just get my constants up to make sure right is in the right. So right is there on bit 3, 0, 1, 2, 3, and fire is on bit 4. So if we've pressed right, we should be, that should be, I'm going to say it's on, but it's not, it's off because we do an EOF at the bottom, EOR at the bottom. So that should be, that's not right, is it, Andy? That's not right. Or is it the way round for the Vic? Was it set? The C64 it goes low, doesn't it? When you press the joystick, it goes from a 1 to a 0. That's why we do the EOR, the exclusive OR. Would it? I presume the Vic is doing the same thing. No. I mean, this gives me the impression it doesn't, because it's just ANDing with 28 and ANDing with 128. But the others, up, down, left, right, are working, so it must be right. So I must be doing something wrong here. So let's just check. 37154. 37154 is 9122. Oh, 9125. 37154. So we're storing 127 in 37154, which is 9122. Then we're loading 37137, 37137, which is 9111. but I'm not. Is that what I'm doing wrong? 3, oh no, it's that one, isn't it? 97152. That's 37152, which is 9120. That's right. Maybe I got it. Maybe I was storing it in the wrong place. Let's try it again. Okay, here we go. Oh my god, got the wrong one. I just walked into that. Boom. Right, the score's a bit out. Score. Oh dear. That's well and truly out. We need to. Right. Okay. So the score's 1 too many over, and the lives is 2 not enough. Okay. Let's go into the game constants. So the Vic score. Oh no, it's not that, is it? It's storage. Here we go. So the Vic, so the score is 1 too far over. 0, 1. Or is it? Let's run it again. Let's just make sure. Yeah, it's 1 too far over, so I need to pull it back by 1. So, the score is 1 over too far, so that's probably 1 over too far. But the lives is not far enough. So let's make that a 5. Right, just see if the scoring now. That's better. We've got proper scoring. Come on then, kill me. Right, do my lives go down? Yes. Cool. That's going all the way across, isn't it? But I noticed when it builds it was 1 short. Oops. Yeah, it's 1 short. Set up. It's 1 short on the horizontal bars. Horizontal, here we go. Draw horizontal bars. That's why. That's why. Right then. So here we go. The VIC-20 version. That's better. Right. Using the same source code but a different configurator. So if I close this down and open up the pet version, same code, different F6 on that. Oh, it failed. We've done something. What have we done? Missing token. Game setup. What have I done? Oh, it's there. Same here. Why is it complaining about that when it's there? Oh, hang on. Forgot that, didn't I? Silly me. Right. F6. There we go. Same code. Now running on a pet. Ooh. That's what I've just changed as well. There. S64. Nice. There we go. It's better. Oh no, it's still not working. Okay, so it's not that. What have I broke? What have I broke? Oh, we don't have a raster line, do we? Don't have a raster line. So we don't have a raster line in, so we need to put a delay in there, I think. How much of a delay? Yeah, that'll do it. If someone's internet's broken, there we go. Let's fix that. So that's the pet version of GridRunner. And then, using the same source code again, we should be able to open up the 64. F6. Bingo. Look at that. So there we go. We have got the same game on 3 different systems using the same code. And I mean, you could split it out, but then you're having to find which bit you're in. At least with the inline modification here, you know exactly this bit's going to be running for the VIC, this one's going to be running for everything else. Almost like magic. Handy magic. Up C16 next. Yeah, I've got the book. I've got to read up about it. Try and find all the quirks of that. But thank you very much, guys, for joining. Is there anybody online? Hayes is online. Hopefully you've learnt something and be able to I know, mate. Hopefully you've learnt something and be able to incorporate that into your the coding, especially if you're going to try and code something on multiple platforms. All right, right, here we go. Let's raid somebody we want to annoy. Here we go. I'd like to thank all the patrons that are contributing to my channel. Without you guys, I wouldn't be able to do what I'm doing right now. Thank you very much.